Well, thank you for having me. As mentioned, my name is John Merrill with Geosyntec Consultants. I'm an engineer in the San Francisco Bay Area. We've heard a lot today about treatment technologies for PFAS and developing new technologies, which is fantastic because we need additional options for addressing PFAS in the environment. And the focus of this project is developing a framework to assess these new technologies and using a lines of evidence approach. Here's our project team. Rula Deeb of Geosyntec is the PI. David Sedlak of UC Berkeley is the co-PI. Jennifer Field of Oregon State University, Chris Higgins of Colorado School of Mines, and Mike Kavanagh of Geosyntec are technical advisors. And then Elizabeth Hawley and I are task leaders on this project, and the project is funded by StartUp within the Department of Defense. So the motivation behind this project, which I touched on some already, it should be clear for most or all of us in the room that there's significant interest in funding and efforts that are being put into developing PFAS treatment technologies. If you look at the pie chart on the right side of the screen, you can see StartUp and ESTCP funding during fiscal year 2022 for PFAS projects. And of their PFAS projects, nearly half, 21 other projects are focused on PFAS treatment. And this spans many industries: remediation, drinking water, as we've heard today, wastewater, waste management, et cetera. With this interest in developing new treatment technologies, we've also seen success claims in recent years for innovative technologies where there may not be a complete understanding of the technology, formation of byproducts, removal mechanisms, effects on PFAS precursors, et cetera. I think this is due in part to a lack of clear guidelines for researchers. PFAS are complicated. There are specific PFAS considerations that need to be made that you may not need to make for other historical contaminants. And so the motivation and the focus of this project is to help develop those guidelines. The high-level objective is to develop lines of evidence, best practices, decision tools, and recommended metrics to better assess the performance of PFAS treatment technologies. Conceptually, I like something like this, where at the top of the screen, you have a PFAS treatment technology, and then using multiple lines of evidence that are fed through a technology evaluation checklist, we hopefully end up with an informed technology assessment. Here's some of the expected benefits of the project. For both technology developers, as well as reviewers of technologies, and also those that implement the technologies, so say consultants, providing them with clear metrics for technology effectiveness, and then especially for the developers and reviewers, identifying knowledge gaps for future testing and development of the technology. Also, to accelerate the development of promising technologies for PFAS treatment and improve the return on investment, practically identifying the most promising technologies and then developing them in the most efficient manner possible. Here's the project approach. We're on the tail end of the project now and working on technology transfer. We started the project and with our project team that I listed, developed draft lines of evidence that we thought we were of the utmost importance. We then brought those draft lines of evidence to an expert workshop. I was at a StartUp ESTCP annual meeting and obtained feedback on the lines of evidence. Based on the feedback that we obtained, we refined our lines of evidence, and then we included that in a final report, which has been published to the StartUp website, which I'll talk about. And now we're working to talk about our findings, such as presentations today. So here's the reference guidance document. Again, it can be found on the StartUp website. Within the document, we talk about the lines of evidence, as well as best practices and other considerations, which I'll talk about during this talk. And then we also include our technology evaluation checklist. We're also working on developing fact sheets that'll include the same information, but in a boiled down more digestible manner that will be posted to the website soon. So diving into the lines of evidence, we decided on 3 lines of evidence, and I'll run through. So first, a decrease in target PFAS concentrations is observed and explained in the context of the mass balance. Line of evidence number 2, the treatment mechanism proposed is consistent with previous studies supported by data. And then line of evidence number 3, the PFAS treatment transformation products have been identified and quantified. So diving into a little bit more detail for line of evidence number 1, a decrease in target PFAS concentrations. To evaluate this, first you need to define your PFAS of interest, and we've heard a little bit today about how we may have different PFAS of interest depending on where you're conducting your work and maybe perhaps what regulatory guidance values or promulgated values you're dealing with. So are we talking about PFOA and PFAS? Are we talking about a broader suite of targeted PFAS, say PFAS included in EPA method 537? Or are we talking even broader, perhaps looking at a top assay or total organic fluorine? Then once we've defined the PFAS of interest, we think a mass balance needs to be conducted, looking at the ins and the outs of the system, and then also considering gains and losses. So I've included some of those on the right side of the screen. If we're seeing a decrease in PFAS concentrations in an effluent stream, is that decrease due to the treatment mechanism, or is that decrease due to maybe other confounding factors, say accumulation of PFAS at an air-water interface or other interfaces? Line of evidence number 2, the treatment mechanism is supported. Is the mechanism consistent with known chemistry of PFAS? Is it a plausible mechanism? Is the mechanism already known or proven? If the mechanism hasn't been proven, it doesn't necessarily mean that it's not occurring, but it may take more robust testing to really prove that the mechanism is occurring, as opposed to, say, absorption technology, which is relatively proven for PFAS and other contaminants. What is the evidence that the treatment occurs to the expected mechanism? Can we, again, prove that the treatment, a decrease in effluent stream is occurring due to the mechanism or other factors that may be affecting PFAS concentrations? And then typically for PFAS, we're lumping our treatment technologies into 2 groups. So either sequestration, such as absorption to activated carbon, ion exchange, or other more novel absorbents. We heard about biochar, or transformation and destructive technologies, which have especially been gaining interest as of late. So as an example, thermal combustion or incineration. The STAR-X technologies are an example of a combustion technology. Line of evidence number 3, transformation products are identified and quantified. So we're talking about shorter chain PFAS, fossilized PFAS, and fluoride. What other products may we be generating with the treatment technology, especially if it's a destructive technology as opposed to a sequestration technology. And by quantifying these products, it can help gauge the efficacy of PFAS mineralization, especially by using a mass balance and closing that mass balance. We can see where the fluoride in the system is going. And it can help you understand the mechanism at play. Outside of PFAS, it is also important to identify other things that may be occurring as a function of the treatment technology. So say if you have an in situ technology, as an example, and you're changing the pH of groundwater, perhaps you could have metal mobilization at your site, and you could be decreasing PFAS concentrations, but have another human health risk that you're now creating. We also identified best practices and other considerations. So these didn't quite make the lines of evidence short list, but we think that these should also be considered when evaluating a PFAS treatment technology. So we identified 5 best practices, and I'll run through. Number 1, using verified analytical methods for PFAS that are commonly analyzed. EPA 537, 533, et cetera. When we're talking about PFAS precursors and other PFAS that are may not fall within these analytical methods that are already verified, using established research analytical methods. So methods that have already been published in literature, or really validating your method that you're using. Number 3, follow and document laboratory best practices for sample preparation and analysis, especially as we can have low bias by, say, as talked about, PFAS accumulating at interfaces. Let's do our best practice to avoid those biases. Similarly, including controls in the study design, number 4, and then finally number 5, accounting for statistical significance in study design and presentation of results. What are the data truly telling us? And then some additional considerations, evaluating the effect of PFAS mixtures. So if we have more than one PFAS, what kind of effect could that have on your treatment technology? And so if we're looking at an adsorption technology, maybe the effects of competitive adsorption. That can be both PFAS, or it could be co-occurring contaminants, say common contaminants that you would commonly observe at an AFFF release site that may be found in a treatment stream. And then also the effect of other water quality parameters, I'm sure pH, ionic strength, DOC, et cetera. These variables that change site to site. Evaluating the long-term treatment performance. How long can the treatment technology be deployed? The generation of harmful byproducts that we talked about some already. So either non-PFAS or PFAS harmful byproducts. And then finally, as you're moving from the lab scale to the field scale, looking at the value or the cost of your technology compared to other available technologies. Is it cost effective, or is it much more costly than the already developed technologies such as activated carbon and ion exchange?
2.5 minutes left.
Thank you. And I'm just going to conclude talking about the decision tool and recommended metrics. So this is the technology evaluation checklist that we created. This is included in our guidance document. So you can go through these questions, and it'll help guide you through a technology assessment and help identify some of those knowledge gaps that may be occurring and help you prioritize follow-on work for your technology. With that, that's all I have. So here's my contact information. Feel free to reach out if you have any questions, but also happy to fill questions now if there's time.
Yep, we have a couple minutes for questions. So far, none. Do you have any advice for us from these guidance?
Yeah, I think that we've had a lot of technology development, especially in recent years. And I think there's a lot of lessons learned from others. And so the goal of this work is to try to incorporate those lessons learned so that we can be more effective for the development of additional technologies or continued development of technologies.